The global, free exchange of information and data over the Internet is changing the world. Consider how online education initiatives allow people in remote locations to be taught by the best educators in the world. Medical doctors can collaborate over long distances to provide us the very best diagnoses, procedures, and treatments no matter where on the globe we reside. And of course, instant information sharing via Facebook and Twitter is forever changing how we connect socially, politically, and economically on a global scale. What if we could share information and data about the Earth's limited natural resources as easily as sharing a video on YouTube or an article on Wikipedia? Specifically, imagine how the free and open global sharing of information about water has the potential to improve lives everywhere. About 1 in every 6 people do not have access to clean water. Some estimates suggest that more than 5,000 children worldwide die each year due to poor water quality. Water at the right time and in the right place is necessary for agriculture production that feeds the world's population. Floods are by far the most expensive natural disaster, causing an average of $85 billion in damages each year, and in recent decades this number is on the rise. These problems can be addressed through better forecasting, response, and water management, all of which require rapid access to reliable data. Enabling global free water data sharing will require leveraging the social internet and close collaboration with scientific, government, and private agencies that study and manage water resources. Historically, water data sharing has been hampered by 4 widespread challenges, including lack of standardized data sharing methods, high cost of data management software and hardware, need for personnel trained in information systems, and in many cases, a culture of not making data publicly available. Several organizations have recognized and are addressing the need for water data sharing standards. For example, the World Meteorological Organization, or WMO, has established a vision for global data sharing and coordinates efforts throughout the world. The Group on Earth Observations and its flagship project, the Global Earth Observation System of Systems, or GEOS, is working to extend technologies for remote sensing and data sharing globally, and in particular, to developing countries. The Open Geospatial Consortium, or OGC, creates standards for sharing map data, and recently worked with WMO to make a new standard for sharing water information across the web called WaterML. The Consortium of Universities for the Advancement of Hydrologic Sciences, or QUASI, has provided the hydrologic information system that serves as another important piece of the water data sharing puzzle. The HIS includes tools to find and share data on web-enabled maps using OGC standards. A research team at Brigham Young University in Provo, Utah, is working to bring these standards and technologies to water management agencies in Latin America in an effort to remove the barriers to data sharing. This team is led by Dr. Jim Nelson and Dr. Dan Ames and students in the Department of Civil and Environmental Engineering that formed the BYU World Water project. The vision of the project is to help overcome cost and technology barriers in order to facilitate global water data exchange. Key initiatives include developing an international version of the Quasi Hydro Server and Hydro Desktop, free and open-source hydrologic data sharing software tools, piloting an outreach project in Central America to promote the implementation and adoption of these tools, expanding the reach of all of the tools and standards embodied in the GEOS vision as both contributors and consumers. The following case studies from Latin America illustrate how BYU is adapting Quasi and GEOS tools and technologies to real-world needs and demonstrate the potential for use by other countries. The case studies are used to highlight how the international version of Quasi's Hydro Server can help overcome limitations to water information sharing mentioned previously. The valley of San Pedro Sula is the breadbasket of Honduras and responsible for a large part of their agricultural production and overall economy.
The San Pedro Sula Valley Flood Control Commission is in charge of developing a variety of water management projects, including flood protection for residents in the valley. However, we are handicapped by the lack of information available to make important analysis and designs. The lack of information, hardware, software, and trained personnel means important decisions are made with empirical and simplistic models and compromise our ability to effectively manage our water resources. In 1998, after Hurricane Mitch, the international community was anxious to help our situation, and many donations and investments provided us with new telemetry and other hardware and software systems to help us better manage water information and provide flood warning. Unfortunately, we could not sustain either the maintenance costs of software or the technical support. Because of this, in just a few short years, all we had were text files for the telemetry stations still operating, but no software or ability to interpret and use them.
An important aspect achieved through this pilot project has been to decipher the codes from the older program and create a quasi-HIS hydroserver database founded in recognized standards. This database is now operable and being hosted on the BYU World Water server, even as the Commission in San Pedro Sula is taking steps to acquire their own servers and take over complete management.
I am happy to participate in this pilot project, and along with the help of others, we hope to increase our capacity in hydroinformatics to benefit all of the vulnerable people in the valley.
While the benefits to having an updated system that is cost-effective, based on international standards, and capable of linking other governmental institutions and international organizations, the real beneficiaries will be the 8 million people of Honduras.
First of all, the direct beneficiaries of the program will be the 2 million inhabitants living in the Sula Valley, where we are actually implementing the project. But finally, because of a multiplying effect, the rest of the 8 million people of Honduras will benefit by extension. Logically speaking, this will make government investments in infrastructure made by the Secretary of Planning and Development in these areas more effective and productive, and overall, in the majority of cases will result in lower costs. Secondarily, making the most vulnerable zones more protected, we can recover agricultural areas and make our country more productive. This will have the effect of increasing the quality of life for all Hondurans, in reality providing them a better standard of education, health, economy, and raise us to the level of more developed countries.
In Guatemala, CONRED is charged with the national coordination of response to disaster, including flooding. While there are other agencies charged with the management of water information, CONRED manages their own rainfall and runoff telemetric collection network for the purposes of evaluating flood and landslide risk. They have used their own local data to enhance and improve forecasts derived from global satellite and remote sensing products.
Everybody needs information to classify the behavior of floods and associated landslides. Most of our investigations are limited to small areas because of a small budget, but using a wider network of help and tools, we can calibrate our models better, add more detail to the analysis, and better forecast future conditions on a larger scale.
CONRED has established a hydroserver with the idea that other agencies in the country and region might also store their information in the same or similar standards-based system. This will not only allow the information to be shared, but the scattered expertise of people with the capability to interpret, analyze, and develop new products important for managing not only flood warning, but all other areas of water resources can be aggregated in a way that all can benefit.
In our country, we need more people working together in water information management. Using our primary information and models, we can provide better management and governance tools and information in the cloud like hydroserver and other applications that are more costly or require deep training will help us develop the required results to better manage water.
INITER is the National Institute for Terrestrial Studies in Nicaragua. and they have been working hard the past several years to advance to the point where they can better prosper from global information products and a wider network of expertise. To do so, they have felt that two things were important. First, that they develop a national map-based data of hydrologic information, and second, provide a way for their information to be more accessible.
INETER is the organization responsible for monitoring rivers, lakes, ocean, and groundwater. However, we have many people who want to use our information, including government and private institutions. They deal with a wide variety of water resources, including agricultural, domestic, energy, and tourism. To date, we charge a fee for the information, but this restricts its use and the benefits derived, so we think we should make the data freely accessible. Making the data free will allow these technicians and scientists to use the data to generate important knowledge about our water resources. This is what we want to see happen with all of our data, and this network quasi allows us to share the data using world standards. We trust and we have faith this will generate more knowledge about water resources in our country.
As they were already working internally to establish the goal of creating an open standards-based system that would allow for easy distribution, they met the opportunity to join the BYU World Water Hydro Server pilot project with great enthusiasm and something that is very timely.
Hydro Server Lite is an important tool for us, and that will allow us to manage our hydrologic information according to standards like WaterML. This will make access and sharing of information easier. It is very important to us and represents a major step forward for us in the way we access information now.
INETER is truly becoming and has the potential to be a leader in the Central American region and the world as it continues to develop the capabilities and demonstrate how other countries can do the same.
Nicaragua is in the center of the Central American region, with 7 countries from Guatemala to Panama. Each of these neighboring countries share transboundary hydrographic watersheds. If we are successful in making our participation concrete in this worldwide network of water information sharing, then we will be facilitating the use for our data. This sharing of hydrologic data among countries will lead to improvement in the management of our watersheds collectively. This data will help us perform hydrologic studies. Without data, we have no studies. And without studies, we do not have knowledge. And without knowledge, we cannot improve the conditions of our watersheds.
INDRI, the Instituto Nacional de Recursos Hidráulicos, in the Dominican Republic, has been a leader in the region, developing a hydroinformatics program and policy that allows for easy public dissemination of historical water information. In March of 2012, their director, Frank Rodriguez, officially announced the Hydro Server portal developed by a cooperative effort between BYU and INDRI. For the past 2 years, much of the historical data available for the Dominican Republic has been available in a hydro server. These students explain how open sharing of data through the hydro server has made data access and accompanying studies much easier.
INTEC is a private university from Santo Domingo, Dominican Republic. It's now considered the best engineering university in the Dominican Republic. Well, you usually go to the INDRI or ONAMED, ask for some data from a shed, I think it is called, and they will give you the data. They say that in 1 week you will have the data, but you often take, I don't know,
2 weeks, 3
2
weeks.
weeks, 3 weeks, a month.
It's more easy the work. We have the ability to take that data and use in projects in the university, plans and other things.
Even the engineers have to take the data from the INDRI or ONAMED. This will make everyone's life easier. for even the students, the engineers, for everybody who wants hydrologic data from the Dominican Republic, from each point of the Dominican Republic rivers and sheds and all of that. It's like a really easy way to get the information.
Yeah. Well, I think that the program is a really great database for all the hydrologic information in the Dominican Republic, really. And I appreciate the information, really. They can help us.
The most important impact of the project is that the GIAS and specifically the BYU efforts are actually reaching the front lines, where the greatest benefits can be derived.
We truly thank the entire network of people working with BYU to develop a system and a global network for the management and dissemination of hydrological information throughout the Americas, the Caribbean, and in the future other parts of the world. Because of the danger to human life and valuable infrastructure that is important to the development of countries, it is critical to have the ability to prepare for extreme events.
A World Water Information Management System has the great advantage of providing a bridge between information generators in all countries, information that is standardized, verified, and accessible to everyone for the benefit of everyone.
We see in Quasi and joining a network of sharing hydrologic information an opportunity that is very timely and believe it will be the same for other countries. When they see what these tools do and the kind of work it facilitates, they will understand the great difference it can make. So I invite you to keep making these efforts so that all countries may be able to enter this network, and we intend to make efforts so that at some point we will be able to share our data in this global network. Thank you for Quasi.
That was the best program I ever see because they have all information of that about hydrology information in from the rivers and other sites in the country. That's what really impressive.